Mars forgives many mistakes, but spacesuit failures are not one of them. The atmospheric pressure there is less than 1% of Earth's. Imagine you were walking and accidentally bump into a sharp, jagged Martian basalt rock. The fabric tears. A hole of just a few centimeters is enough to start an instant biological nightmare. The first event is explosive decompression. The pressurized air from your suit leaks violently into the environment. The human instinct is to hold your breath, but that would be a fatal mistake. Your lungs would expand until they rupture. The air is sucked from your lungs. In seconds, you run out of oxygen, inhaling the thin Martian atmosphere composed of 95% carbon dioxide. Due to the almost non-existent pressure, the boiling point of bodily fluids drops drastically. This causes ebullition. The saliva in your mouth, the tears in your eyes, and the moisture in your lungs begin to boil immediately. Gas bubbles form in your blood, swell in your tissues. Your body can swell up to twice its normal size, but the skin is strong enough to keep you from exploding. At the same time, the relentless cold attacks. The average temperature on Mars is minus 60 degrees Celsius. Where the skin is exposed, freezing is almost instant. Ice crystals form on the wound and around the suit's tear. And we can't forget the Martian dust. It is loaded with perchlorates, salts that are highly toxic to the human body. This poisonous dust enters through the tear, directly contaminating the exposed bloodstream. The deoxygenated blood reaches your brain. You have at most 15 seconds of consciousness before blacking out completely. Your vision darkens, mental confusion takes over, and your knees give way to the weak gravity of Mars. Without an immediate emergency patch or a nearby airlock, the damage is irreversible. Your heart stops beating in a matter of 1 to 2 minutes due to the acute lack of oxygen. Your body, now lifeless, will begin to freeze solid, preserved by the planet's freezing dry vacuum. The intense solar radiation, without the protection of Earth's atmosphere, will slowly begin to degrade the remaining suit material. Mars is fascinating, but it will never cease to be a brutally lethal environment. A single tear is the fine line between exploration and the end. But what if the tear is small and you still have a few seconds of consciousness? Training conditions astronauts not to panic. The first step is to isolate the leak. The pressure cannot drop to zero. If the tear is on the arms or legs, modern suits have built-in pressure tourniquet zones. You temporarily sacrifice the circulation and pressure of an arm to keep the air in your lungs and save your brain. If the rupture's on the torso, the only immediate salvation is space tape, made of extreme polyamide, like Captain. The astronaut must apply the tape directly over the tear, creating a temporary and rudimentary seal against the absolute vacuum. But this doesn't solve the problem. It merely buys a few precious minutes. From that moment on, the most terrifying race of your life begins, toward the pressurized rover or the base. The dilemma is cruel. Every sudden movement consumes more oxygen and increases your heart rate. You need to move slowly enough not to hyperventilate, but fast enough not to suffocate or freeze to death. To prevent the mission from reaching this critical point, the engineering behind is absurdly redundant. A planetary exploration suit isn't just a piece of clothing. It's an individual, human-shaped spacecraft. It is built with up to 14 different layers of high-tech overlapping materials. The outer layers are made of Kevlar and Nomex, the same materials used in bulletproof vests and firefighter gear. They serve as armor to block micrometeorites traveling at thousands of miles per hour in sharp rocks. Beneath the armor, there are multiple layers of aluminized mylar designed to reflect lethal solar radiation and provide thermal insulation. The innermost and most vital layer is the pressure bladder,
a high-strength urethane balloon that keeps oxygen contained around the body. Even with all this protection, the engineers of the new space race are already developing the future of survival on Mars. The next generation of suits will include biohealing materials based on smart polymers embedded in the fabric. If a micro hole forms, a reactive gel would instantly leak out, solidifying upon contact with the cold and vacuum, sealing the breach on its own. It may sound like science fiction, but real and terrifying accidents have already happened in space. On mission STS-37, an astronaut working outside the space shuttle had his glove pierced by a metal rod. The tear was microscopic. The drop in pressure caused the astronaut's own skin and blood to temporarily seal the hole in the vacuum.
He only realized the mortal danger when he returned to the airlock, took off his glove, and saw the bloody mark. On Mars or in deep space, the margin for error is zero. Extreme engineering is our only line of defense against an unforgiving universe. But let's say you manage to apply the emergency patch. Now, you need immediate rescue. Your first instinct is to scream on the radio asking Earth for help. But there is a terrible problem: the communication delay. Depending on planetary alignment, a radio signal takes up to 22 minutes to reach NASA, and another 22 minutes for the response to come back. To you, Earth is in the past. No one is coming from there to save you. Your life is entirely in the hands of your crew at the Martian base and the artificial intelligence of the rovers. The rescue rover detects the pressure drop and speeds toward you, guided by autonomous emergency navigation. But the physical rescue is brutal. Your partner has to carry your dead weight, plus the heavy 130 kilos of your spacesuit. Reaching the base doesn't mean relief. The airlock is the final lethal obstacle. You can't simply open the door. If you do, the base's atmosphere will escape into the vacuum, killing everyone inside. The repressurization process must be fast but safe. Seconds feel like hours as the air fills the small room. As soon as the inner door opens, the mission medics tear open your $1 million suit without hesitation. You are immediately placed in a hyperbaric chamber to reverse the swelling of gases in your blood and forced oxygen into your brain. Medical treatment on Mars will be primitive. Without large hospitals, your survival depends on modular trauma kits. The tissues instantly frozen by the vacuum must be treated urgently to avoid necrosis and amputations.
Furthermore, your blood needs to be filtered to remove the toxic perchlorate dust that invaded the open wound. If you survive all this, the mission's focus shifts. The damaged suit becomes a crime scene and is isolated in